Hey guys, my name's Jessie, and I wanted to take a second to show you this gorgeous light curve that we created using the Prompt USAS telescope last semester. This light curve was created using observations collected from September to November, and from it we were able to classify YSJ21 as a contact binary.
All right, so that was just a short slide reel showing off some of the images and work that University of Saskatchewan students have done this year using our new robotic telescope located out at Sleaford Observatory. And I'm here with Rena Rast, who's a fourth year astronomy physics student who's doing a capstone project in astronomy this year using the Prompt USAS telescope that's out at Sleaford. And I'm going to open up the roll-off roof enclosure that the telescope is in. There it is. And Rena's going to tell us about her project.
Right, so my project is focused on verifying the classifications of bright stars in catalogs that resulted from all-sky surveys. And this is important because a lot of these objects are novel detections. There's lack of data which corroborate their classification. So what I'm doing is I'm using the Prompt USAS telescope to take images on objects that need follow-up observations so that I can verify their classifications, or if they're wrong, reclassify them correctly.
Thanks, Rena. All right, so the roof is getting close to open here. We can see the telescope has shown up. This window right here is actually, I'm using AnyDesk to connect to the computer that's out there that runs the roof and runs the telescope, runs the camera, and all of the equipment out there. So the camera or the computer is actually located in this cabinet right there. So using the computer, I can click on this star chart anywhere on it and tell the telescope where I want it to go. The telescope has a pointing accuracy of about 0.01 degrees, and the field of view of the camera, which is operated over here, is a sixth of a degree roughly across. And so because of this, because the mount points the telescope so accurately, oh, it's frozen up waiting for that image to come back. Because it points so accurately, we're actually able to run this telescope completely automated, so that a person doesn't have to go onto the computer with the frozen connection and tell it to move around. It's able to connect to a robotic telescope network called Skynet, named after the Terminator movies. And Skynet runs the telescopes completely on their own. Right. So doing that means that students are able to operate the telescope from their homes using just an internet connection and a web browser, because Skynet's operated all on the web. They can schedule their observations at different sky coordinates using different filters. Like I was using the H alpha filter for this image that I took of the sky, and point the telescope to different parts of the sky, giving various constraints. And Rena's actually going to show us that on her computer right now.
Okay. So this is the form that the Skynet Robotic Telescope Network uses to submit observations. So I'm just going to input the name of a galaxy here because it's really handy. You can just search Messier objects, I think NGC objects as well. Alternatively, you could have put in the right ascension or declination, but that's the galaxy I want to schedule images on. I can set this little box here, which basically says the sun has to be at least this low in the sky before you take images. It has to do with how dark the sky is going to be when it's taking images. Minimum target elevation has to do with image quality. When images are really low in the sky, a lot of times your data quality isn't great. I'm setting it so the moon is at least 30 degrees for my object, so I'm not getting moonlight contaminating my images. You can scroll down and you can see so many telescopes here that can be imaging M51. So I'm just going to save and choose a telescope. And again, the whole list of ones that I could look at, ones in Alberta, bunch in the US, and I'm just going to pick prompt USask. And there's a whole list of filters I could pick as well. There's ones that are used mostly for science imaging, so ones that I've been using for my project, and also ones used for astrophotography. So I'm just going to do red, green, blue, luminance, and also H-alpha. Save and continue, and this page is where you can choose how many exposures you want in each filter, and also how long those exposures would be. And it shows me the total amount of time that's going to use up on the telescope, how many credits are going to be needed. I can pick which account I'm going to be pulling those credits from. This repeat observation is really helpful for doing things like my project, where I'm imaging the same object repeatedly over a given amount of time. Once I save and continue, I end up with a page sort of confirming everything that I just put in. And once I say submit, then it's going to be in the queue and the telescope just waiting for it to get dark. And then we'll be able to take those images, and I'm going to check back in a bit.
Great. Okay. Thanks, Rena, for showing us how we use Skynet and access our telescope, and how other people around the world access our telescope at Sleaford using the Skynet website. We're going to sign off now and come on later at night. It's daytime now, so we can't do astronomy. We have to wait for nighttime and show how the telescope works behind the scenes. All right, so it's nighttime, and Rena and I are back to show off the telescope working at night. So you can see here that this Terminator app that runs the telescope from Skynet's website, it's currently taking in exposure. This will be a picture of a galaxy. There's a picture of a galaxy sitting right there, and so it's actually going around taking images of galaxies for a research group that's doing a supernova search project. And then we're going to pop the telescope into manual mode, and Rena and I are going to take some pictures of some other objects here just to show it off. So where do you want to go first?
I was thinking M101, the pinwheel. It's just a really nice spiral galaxy that's face on. It's really big.
Let's try a 45-second image of that.
Nice. That's really nice.
All right. Well, thanks, Rena, for the tour of the galaxies.